Today we are doing medium problem 3296, minimum number of seconds to make mountain height 0. So we have a single mountain of some height, and then we get worker times. Now each worker can reduce height by something of this mountain. And first reduction takes like 2 seconds, then it will take 2 times 2, 2 times 3, 2 times 4, and so on. And they operate simultaneously. So the total time required is maximum spent by any worker. And we want minimum seconds required. So minimum maximum in a single thing should tell you like binary search, because if we can do it in time 20, we can do it in time 50, 18 billion, right? So we want to, and then if we get time, you can see that even if worker time is 1, this increases like quadratically, right? Because if you write this out, if you sum this, you take out worker times 1 plus 2 plus blah 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 up to x, which is x times x plus 1 divided by 2, roughly x squared. So it's like square root of height of mountain times number of workers, which is like 10 to 6 times logarithm. Could pass. Let's do CPP. Okay, so I mean most seconds will probably take mountain height, so L mountain height, no, this is mountain height, and then while L is R, Python thing. And then we're gonna do like, so we can work at most this much. So current mountain height for int worker times, and then we do, can we find this? I mean, technically I could do like log square root x, another binary search here to achieve optimal time complexity, but we could do like int x1, and now while let's do total, right? And then while total plus worker time times x is less than or equal to m, then current height if current height less than or equal to 0, so we could reduce it, then we can do it in at most this many seconds. Otherwise, we have to do it in more seconds. So turns out I'm stupid, and not because of this, but what do you mean in 2 seconds, bruh? So worker time 2, and we got 2 seconds. So first worker can work once, second worker, how is that possible, man? Because total. So if 2 each can work 1 second, so height will remain at 1. No, I wasted a submit. You kidding? Of course that won't pass. Okay, now second one doesn't work at all. That's great. Oh, it could take way more seconds. Yeah, it will take like worker times size. Let's call it like n, and then it will take like some ceiling. This is a trick to calculate ceiling division. What are you talking about, bro? Okay, yeah, that could take a lot more. So I don't know. How much could it take most? Like square root of mountain height. Who cares? I need a better bound to pass. It probably won't even pass. Wow, even more seconds. That's great. Okay. That's kind of weird, but we are passing all but 3 cases in like no time, so could make this binary search to achieve optimal, but could also do this, but that doesn't work, so I mean, what we want to get, it's like x times x plus 1. Because, okay, let's say, like we want to figure out that worker time times x times x plus 1 divided by 2 should be less than or equal to m. So from that we get m divided by worker time larger than or like 2 times this should be larger than or equal to x squared plus x. So if you do square root, can immediately like start it at square root m. In square root will be this. That's tough. Ah, that's why I'm overflowing. Best practice, always spam long everywhere. What? Okay, this almost works out. Time complexity wise we don't need that. This should do like okay, this will be slow, but I mean, what am I supposed to do? What? That is not passing it. You have to be kidding me. What? So we take max element. And then like max times something like that. No, that's dumb. this times, I mean technically it could take this long. Okay, that's fast. Please pass. I don't wanna. Oh my days. So x should be like I don't need total, and then okay, I mean we are getting there. I think this is all one, so I think I have log n. Maybe I don't have the right number of iterations. What is this? Okay, solving this inequality using quadratic formula. Damn, okay. Okay. Oh, I got this actually right. Okay. Oh, one floor. Okay. It didn't help anything, but that's okay. What is plus epsilon? What the hell? That's so dumb. I wonder what's the max amount of iterations. Max. Let's see. 2, 3, 2, 29,000. 29,000. Oof. Food, that's a lot of iterations, to be honest. Why? Okay, this decreases them even further. 26 milliseconds. Now it takes 1, 1, 1, 1. Oh, one iteration every time. Okay. So technically I can straight up just do this. No, I can't. Because, you know, there was always just a I need to do this. What? Am I dumb? I have to be. Something is wrong. It's probably because maximum values, but I don't really want that, to be honest. I guess it's plus minus 1 error. Ah, 0, 1, 0, 1. Okay, I guess I'm willing to live with that. I think for depends on both number parity. M and 1. Yeah, okay, not the pattern. I guess that's okay. Okay, let's write a solution. I mean, that's like a competitive programming task, I would say. Space, oh, 1 for sure. Okay, so whenever you see minimum, maximum of something, it's usually worth to try finding a binary search. In this case, if workers can what? Make mountain height 0 in t seconds, they can make it have height 0 in s over t. It's like for all s in math bb n st. Okay, and now what we do? Now how to find, okay, so now we just need to find out how much height can each worker reduce the mountain with in m seconds. Notice that reduces the height by x, some of the it will take x which is equal to I don't want to use align right now. Maybe I could. It will take begin align okay, so there is no align. C dot x, C dot frac x my god, L floor frac what? Now we want to find largest x such that I am not willing to write it again, so x is equal to square root of 2m now. Okay, so this way we can calculate for each worker by how much will he reduce the height of the mountain in m seconds in O1 height of the mountain with that will be left after m seconds. If it's length 0, we set complexity since we do not really. So lower bound on the search is 1 and upper bound on the search is c dot l floor frac air floor mountain height since we do O log m iterations and each takes OM. Since that's how much would it take for the slowest worker if he would work alone. Ridiculous. See you tomorrow. Maybe different platform, I don't know. We will see what I do because my dumb ass didn't check Google Jobs every day. I just relied on subscribing to whatever, to some choice, but I only got now email for PhD intern, which I'm not, and then I got an email for some Entwicklung garbage, basically for German speaking speakers to teach some coding. I just missed it. I'm so dumb. Whatever. We'll figure it out. Bye.